adding alpha plus beta. So let's say here's alpha, and let's make it a large beta, right? So here's beta. So together these make alpha plus beta, and that's going to take us to this point P1. And what are the coordinates of P1? This is a unit circle, right?
What is the what?
The coordinates of P1
P1.
in terms of alpha and beta.
What is that?
Well, let me start with the coordinates
Oh,
of
7.2 in the book. Gotcha.
of this point. So this is going to be cosine alpha, sine alpha. Why is that?
Cosine alpha, sine alpha. X and Y.
That's a definition. That's how the sine and cosine functions are defined. Right? Assuming that this is the radian measure of this arc, right? So the radian measure of the arc is numerically equivalent to this length because the radius is 1, right? So you take the radius of arc length to radius, the ratio, did I say radius?
Yeah.
The ratio of arc length to radius is the, is it invariant? And that's why it's a good use for the measure of the angle. And in particular, when the radius is 1, then that ratio is in fact the arc length. Which, so you have both the radian measure of the angle and the arc length be numerically equal. They're not dimensionally equal because the arc length has units of length and the radian measure of the angle is dimensionless, right? Because it's a ratio of length to length, where the length in the denominator is 1. Okay, so that's how we define x and y are the terminal points of the position on the circle you get by traveling a distance alpha around the unit circle. So if you travel a distance alpha plus beta, then what are your coordinates? Well, what's your angle? Alpha plus beta, right? So the x coordinate is cosine alpha plus beta. What's the y coordinate? There's a lot of space here, so I'm going to put sine alpha plus beta, right? So that's this point here. Yeah. And this, I guess I need unmatched to match my parentheses. Okay, so I'd like to use the distance formula to find this distance from P0 to P1. So what's the distance formula?
D squared.
So like x1, x2 over y1, y2 or something.
It's not over.
No, x2.
What, no, x
Two plus-
x2.
So where does it come from, the distance formula?
2 points.
Where does it come from?
Yeah, which
Well, that's how you derive sine. You
Does
need the
it
distance
come from the
formula.
Pythagorean theorem?
Pythagorean theorem. Yeah, exactly. Right. So what are the sides of this right triangle? Well, the height is going to be, so the point here is 1, 0, right? Right. So this will be all right. Yeah, I can say x minus that, right? So so this distance here is 1 minus cosine alpha plus beta, right? And what's this distance here? That's going to be the y minus that y, right? That's going to be sine alpha plus beta minus 0. Right? So you take the difference in the x coordinates to get this horizontal edge. You take the difference in the y coordinates to get this vertical edge. Those are perpendicular. The hypotenuse of that is the distance between them, right? So I'm going to say that the square of P1, P0, P1, right? Y, the square, because then I don't have to write square root on the other side. Nobody wants that. Okay, so this is going to be the square of 1 minus cosine, alpha plus beta, plus sine alpha plus beta minus 0. Right, is that agreeable? That's just Pythagoras' theorem.
Yep.
Also known as the distance formula in this case, right? Giving you the square of the distance actually, but that's all right. Can we expand this and combine? Would that be a good thing? You should always ask yourself, would it be helpful to expand? Because oftentimes it's not. I saw people on the last exam expanding a binomial to the 5th power. It's like, not helpful in that case? So, think about whether it's a good thing to expand. Is it a good thing to expand here? Yeah, why? What will we get when we're done expanding? Pay-dirt, which is a tingling of the pay-dar. Do you see it?
No.
Well, that one is
Okay.
You're going to get cosine squared plus sine squared at the same angle, right? It's going to be part, not all of it, but it'll be a big part of it, right? So, let's see, so the square of the first is 1, twice the square of the 2 is this,
Oh, no, I'm not doing that yet. I don't think so.
and then the square of the second.
Those are-
Now here, the minus 0 doesn't count for anything, right? So it's just the square of this. So it's going to be the square of this. And what is all of that? Well, that's 1. Right? So this comes out to 2 minus 2 cosine alpha plus beta. Well, that didn't get us what we want. Does it get us anything? In fact, yeah, I'm a little worried about this, right? So we're actually going to get this one. So this turns out to be cosine alpha, cosine beta. So it's curiously different, right? And you'll learn to memorize these things. Minus sine alpha, sine beta. You're going to want to memorize these addition formulas.
Yes.
So how do you memorize things?
Looking over.
Take a picture of it? That's the modern way. Then you don't have to remember it, because you got a picture of it. Yeah, it'll last longer. Yeah, the modern age. It's mystery. Well, scientists are coming to a better understanding of how memories are formed. Brain chemistry is at work. What are you doing in your brain when you form a memory?
There's a synapses that connect. Probably things wrong.
Synapses
Yeah.
and axons and all that stuff. Well,
They're firing and they
yeah,
make a
they're firing, but how
connection.
they find regular pathways that they can fire on. And how do you form those pathways? Well, it's like a molecular sheath. I think it's called a myelin. Yeah, you've heard of these things? Yeah. So it's actually a physical process that only works if you concentrate on it and think about it and practice, right? Okay, so we have this. Okay, so now how are we going to get what we want? Well, let me erase some of this stuff because I want to write other things on here. I guess that's all right. So I'm going to take this chord with this subtend central angle alpha plus beta and rotate it around. I'm going to rotate it so that this coincides with the x-axis. So I'm going to rotate it a distance or an angle alpha. All right, so that's going to give me, this is alpha, and then this has got to be beta, right? So beta was almost 90 degrees, so it's going to be like that. All right, so this angle is beta now. So alpha plus beta will give me 2 points here. I'm going to call them Q0 and Q1. This is, using the same nomenclature as in the book. And then I've got this same distance, right? This distance from Q naught to Q1, it's a chord subtending the same central angle in the same circle, right? It must have the same length. Two chords subtending the same central angle have the same length. Okay, so now I'm going to use the distance formula on that. So Q naught Q1 squared again. So I need to find so what are the coordinates here? Well, the angle is actually negative alpha, right? Because why negative? Well, because it's going clockwise, right? The positive direction is counterclockwise. So if you go clockwise, you're going to get cosine of negative alpha, sine of negative alpha as the coordinates there, right? Which cosine is even, right? So what's cosine negative alpha?
Cosine alpha.
Yeah, it's just cosine alpha. And sine is